Hi all, I am here with my new video on atoms, molecules and ions. Let's start. In this video we will learn about atomic models proposed by different scientists. The Dalton model, year 1803 to 1807, proposed by John Dalton. This model was based on experimental work done by John Dalton. According to this model, atoms are the basic building blocks of the matter. It can be summarized as follows. Each element is composed of indivisible particles called atoms. In an element, all the atoms are identical. Atoms of different element has different properties including mass. In a chemical reaction, atoms are not created, destroyed or changed into other type of atoms. The atoms are simply rearranged. When atoms of one or more elements combine, compounds are formed. Sample of a given compound always have the same relative number of atoms. For example, all sample of water has 2 hydrogen atoms for 1 oxygen atom. The Thomson model. J.J. Thomson proposed an atomic model in which an atom had internal structure. It was an extension of the Dalton model. According to it, an atom consists of a positively charged jelly-like mass with negative electrons scattered throughout it, just like raisins are spread throughout a plum pudding. The Rutherford model, in year 1911, proposed by Ernest Rutherford. According to this model, most of the atom is an empty space. Most of the mass of an atom is concentrated in a dense, positively charged nucleus. Electrons are present in the space surrounding the nucleus. Benefits of the Rutherford model. Rutherford developed the nuclear model of the atom, and a nucleus is the most important part of an atom. Rutherford's model was based on the experiment in which he and his co-workers bombarded the gold foil with the nuclei of helium atom, which is 2He4, and observed how these particles are scattered by the foils. They observed that most of the particles pass through the foil with little or no deflection, means most of an atom is an empty space. Only a small number of particles were deflected at large angles, means most of the mass of an atom is concentrated in a dense positively charged nucleus. A diagram has shown in the next slide. This diagram explains Rutherford experiment in which he and his co-workers bombarded the thin gold foil with the source of alpha particles, which means helium atoms, 2He4, and they observed that some particles are deflected at large angles. Most of the particles are undeflected because of empty space. The current view of atomic structure of an atom is based on its principal subatomic particles. An atom consists of a nucleus which contains most of the mass of an atom and in which protons and neutrons are found. Protons are positively charged and neutrons have no charge on it. Electrons are found outside the nucleus and are negatively charged. On this slide, there is a table containing proton, neutron and electron with their charges and mass. Proton found in nucleus, charge Coulomb 1.6022 into 10 power minus 19, relative charge plus 1, mass in kg 1.6726 into 10 minus 27, mass per unit 1.0073, relative mass 1, neutron location nucleus, charge 0, relative charge 0, mass per kg 1.6749 into 10 minus 27, mass per unit 1.0087, relative mass almost 1, electron found in outside nucleus, charge minus 1.6022 into 10 minus 19, relative charge minus 1, mass kg 9.1094 into 10 power minus 31, mass per unit 0.00054858, relative mass almost 0.0005. A relative charge is one whose magnitude is compared with the magnitude of an elementary charge which is assigned a value of 1. A relative mass is based on a comparison with the mass of proton which is assigned a value of 1. In the next video, we will learn identifying an element and terms related to atoms, molecules and ions. To watch new videos, please subscribe and like. And don't forget to watch our other videos too.